Okay, hello. I'm going to continue with the osdev here. I'm thinking about making the sort of VBIOS extension graphics modes a little bit more generic. So instead of being 1920 by 1080, 32 bits per pixel hard-coded, I'm going to make it more, more generic, more abstract. I want to have the user sort of enter values at runtime when the thing boots up, what video resolution they want. Maybe they want 1280 by 1024 and 16 bits per pixel or something, or 800 by 608 bits per pixel if they have some old system. I don't know. But I just want to make it available to do that and make the graphics mode a little bit more generic. So I'm going to try to do that today. So to start off, I want everything to work exactly the same, but just not have these hard-coded values, right? So in the second stage bootloader, or second stage assembly file here, at the bottom we have the VBE info block and the VBE mode info block. So this mode info block holds the things like, the X and Y resolution, the bits per pixel value, the bytes per scan line values. For the linear frame buffer that we're using, we have these red, green, blue mask field and size positions. So that'll give basically the number of bits within a given color that you want to display, and then where inside of like 1 byte that those bits appear at. So if we have something like, I'll go over this more in a bit too, but if we have something like ARGB values that I'm using right now for 32 bits per pixel, RGB, it'll be these values. So, white, for example, is Fs, all Fs for white, and then black is all zeros, and then blue is something like 0 for the red, 0 for the green, Fs for, blue, whatever. Yellow is like just red and green and no blue, stuff like that. So these RGB values, assume that we have the red, green, and blue at these positions, but they can really be wherever the video mode decides they're going to be, and that's what these, field and mask positions are deciding. So the red mask size will be how many bits of red are in a given, pixel with the bits per pixel value. The green and the blue will be for the green and blue values. The field position is where inside of the byte or bytes that these numbers appear. So if we have something like 32 bits per pixel, red is going to be 8, green is going to be 8, and blue is going to be 8 bits. And then, the alpha channel, the alpha value is also 8. So we'll have, red is two 4-bit values put together for this hex value. And it appears at position, 0, 4, 8, 12, 16. So I think it counts up from 0 though, but the red mask size here would be 8, and the red field position would be 15, which is the 16th bit if counting from 0. So what you can do when you get a color, if you want to convert it between bits per pixel values or other things, you can look at the red, green, and blue mask size and field positions and say, okay, I want, the blue portion of this color to be at wherever the field position is, it'll be 0 for a lot of these. And then the mask size is how many bits are dedicated to blue. So you can basically take the mask size, shift it over by the field position to construct the color. I'll be doing that in a bit, and this is kind of a tangent, but just wanted to get that out of the way because I'm here right now. But I'm going to copy this, the mode info block, I'm going to copy into a sort of C struct, into a C struct inside of the graphics thing here, because I figure it's related to graphics kind of, so I'm just going to put stuff in here. I might rename this and take off the 2D underscore prefix, but I'm going to put this stuff up here, so yeah, I'll just put it above point. So I'm going to call this VBE mode info block, because that's what it is. I'll put holds current graphics mode values, for lack of better stuff. So I'm going to have a struct here, typedef struct, to make sure it only takes up the amount of space that I give it, even though it's not as optimized. I'm going to make it packed. I'm going to call it VBE mode info T, sure, why not? But inside of here, I'm going to put in the mode info block. So I'm just going to copy all this and paste it over here. Don't need that. I'll keep the comments, although I'll replace them with, the C comments. But I'm just going to convert these over to, just bytes and words and things, because this doesn't work as nomenclature within C. So for example, these mode attributes are defined as a word, which is 16 bits. So instead of doing that, I'm going to do, uint 16t Mode attributes, we can define it as 0, that's fine. I think that'll work and be all right. If not, then I can take that off and it'll be, you know, 0 by default if these equals don't work. But I'm going to go ahead and convert these to, you know, uint8 or 16Ts. I just don't want to be typing forever. So these DWs are going to be uint16T. These DBs are going to be uint8T for 1 byte. These DDs are going to be uint32T because their double words are 32 bits. So I'm going to do that and I'll be back in a second. All right, I changed all these values, you know, except for the last one here, the reserve 4, because just I wanted to show, you know, this is times 190 db0, so this is going to be, you know, 190 byte array pretty much. I'm not using it for anything, but it's going to just take up the rest of this 256 byte mode info block. Just wanted to show that one's slightly different because that was times 190 defined by 0. So that's just adding the type def struct here. So everything that includes the 2D gfx.h file will include that now. Just to make sure I didn't type anything wrong. You know, we're still good and it'll still run. So that's good. Okay. So now inside of, you know, where we print stuff to the screen, I can kind of make it more generic since we're including that graphics file in there now. But I also, before I do that, I kind of want to simplify some things a little bit. I don't really, you know, I've been typing stuff twice inside of print character and print string so far. It's really inefficient. That's kind of bad. So I'm going to simplify things a little bit, at least in terms of file structure. I'm going to move print character, print string, and probably also the print dec and hex functions all into one file because they're all sort of printing different types of, you know, numbers or strings or whatever. So I'm gonna put those all into one file. So I'm gonna make a file in the print directory. I'm gonna call it print types or something. We're printing types of things. So that's not the best name, but I'm just gonna call it print. Or wait, I can cat. Never mind. I'll cat it into there, not copy. Copy makes a new file. Let's concatenate that into there with the double arrows. That should include that in that file, and then we can also put in the print string into that file, the print dec, and the print hex. Print dec. And print hex, and then we can look at that. So it'll start with print character, goes to print string, print dec, and print hex. Okay. Just making sure those are all there. So now that these call print string, they won't have weird locality issues, I guess. It'll all be in the same file. And I don't need pragma once everywhere now. I can just put it at the top of the file, which is good. Yeah, right there's fine. I'll actually put it above here. I'll just put that there. So this will be print types.h, print different types of, I don't know, values. Strings, numbers, etc. Okay, we'll do that. And I had one other once down here, didn't I? Yeah, this one. Get rid of that. Okay, the print string can also be kind of simplified to just call print character, so I don't have to double up, you know, work anymore. So maybe I can do that right quick. So this takes a constant string, so what I could do here for print string is just have the loop here. While the string is not 0, we can just call print character with that value. You know, while the string's not null, we can just call print character. So I'm going to comment this out and see if that all works. And if it doesn't, then, you know, I'm a failure at life. That's fine. Okay, and where does this go? Anywhere? That goes up to there. So yeah, we don't want that anymore. Well, I'll do that. Return 0, it's going to return by default. So I can take that out. So just call print character, and then we don't need these things. These will be changing in a bit anyway. So I'm basically just going to call print string, because yeah, that already does all the calculations and all. And I'm leaving all the comments there. So I need to include print types in the other files and the C files, so I'm going to do that right now. So instead of print hex and dec, and character and string, I will include, I'm going to clean this up in a second. I just want to make sure it works. That's why I'm keeping all the comments here. Include print types. The only other two C source files are the calculator and the kernel, so these might grow a little bit because they have more code in them, but they're already including all these anyway, so probably not. So just comment those out. Print types and go to the editor, character string hex, okay. This doesn't have decimal in it yet anyway, so that's all right. I think that looks okay. All right, let's see if it compiles. Nope, I effed it up. Too few arguments to print character. That's true, because it takes in the cursor X and Y as pointers and the character. We can do that here. We'll just pass them along. Cursor X and cursor Y. Control reaches end of non-void function. 252, does it now? 252. That was too much. Here? Yeah, it reaches the end. Oh, this return. What does this return? A uint 16? Oh, the return code. I'm just going to make it a void. I'm going to change that to a void. I'm going to be a bad person and say, because I'm not using return codes right now for even like checking if I'm printing things. I guess that was useful at one point. That's probably bad to take out error handling, right? But that's what I'm doing. And so, yeah, print character doesn't return anything now. It'll just return, get rid of that return 0. Okay. Expected a statement, 125. Oh, from the return here? We can just do return. Instead of return 0, we can just do a return because it's now a void. Okay, and these files are probably bigger now. 1A, 1E, 0D, right? So kernel's 1A. Actually shrunk a little bit. Interesting. Because I'm not including all the code twice. Okay. So 1E for the editor, 0D for the calculator. Okay, 1E is the same, but this is 0D now, which means this is 31. And since the kernel is 1A, this will change to 19. 1A. A, okay. I'm going to make that a little bit easier too. I just don't know if it's in this video or not. Sort of refactoring the boot sector a little bit instead of needing to hardcode values inside of there. I might do that change in this video, I might not, I'm not sure yet. But everything should still work fine. We're just using the different file with all of them in there, and we're including, you know, the VBE. I'm just making sure stuff still loads here, and we can save stuff all right. Okay. So let's get rid of these. Get rid of these things here. Yes, write that. Because I don't need these to be commented out anymore. And all these files. As long as I remember to save. Do that. And this stuff down here in print string, these don't need to be commented out. I know I'm going a little fast. So, but this looks a lot simpler, doesn't it? I'm not duplicating all the work anymore. That's good. That's objectively a great thing. And everything still works, so that's good. So what I'm going to do with that now is get rid of those files. I'm going to remove print character. Oh, that was painful. Print string, get out of here. Print decimal, get out of here. Print hex, get out of here. Look at that. We saved some space. Okay. So how do we make stuff more generic now that we have the VBE info block inside of, you know, the kernel and the other places that have the graphics header included inside of the print file where I just was actually is where we can do this. So instead of, I'm going to change colors in a bit as well, but instead of hard coding here to 9028, which is where it is, I kind of want to give a name to this magic number as well. But instead of hard coding this 1920 and 1080, we're going to be changing those a little bit. I'm going to do it inside of the graphics file here. So we have a type def struct here for the mode info block. I'm just going to make a variable to kind of, what's the right word? Instantiate? Is that maybe the right word to use? Instantiate one of these structs so we have something to work with. So I'm going to call it VBE mode info t. I'm going to make it a pointer. Call it VBE mode info, or I don't know. Is it too confusing if I call it graphics mode? Does that make sense what it's used for? We're saying, hey, I'm going to get the current Y resolution for the current graphics mode. I mean, I think that kind of makes sense. I can change the name later though. But I'm just going to call it graphics mode, and it'll be a VBE mode info t pointer to a location in memory. So right now that location is 9,000. But for the sake of not having too many hard-coded numbers, we'll make a define. I'll call it VBE mode info address. Be very pedantic, very explicit with it, and it'll be at 9,000. So we can change that later. If we use this in more than one place, then I can only change it right there instead of everywhere else. So VBE mode info address is where that's going to point to. So we have a graphics mode pointer to work with. This will be wherever this file is located, right? This 2D graphics.h. So this header and all the C-source files can now use the values pointed to by this VBE mode info address. So we can do like graphics mode with the arrow. So I'll just put this here. We can do stuff now like graphics mode Y resolution, right? Because that is located here within this struct that we just sort of made exist. So it's a pointer, so I can point to here, get this value. I can get the physical base pointer value for the frame buffer. I can get this stuff for colors, so on and so forth. So I'm going to be using that in the print types file to, make things not hard-coded anymore, as well as this file probably. Instead of pointing to 9028, I can now point to graphics mode with the arrow and physical base pointer. It is a bit longer, a bit more to type, but it is more explicit. It's not like, what the heck is that number? So I'll be changing some hard-coded values here. And I guess I'll start with this graphics file because we're already in here. So 1920 in the 1920 by 1080 resolution is the X value, the X resolution. So I can change this to graphics mode X resolution. So it's not 1920 hard-coded anymore. I'll just look through and see what else I can change. If anything else is bad here, yeah, this 9028 or 9028 will be the physical base pointer. It's 1920 again. I have, duplicated code with these. That's fine. X resolution. So yeah, Y times the X resolution plus X. This probably could be changed to be, if I'm getting a certain line in the screen, it won't necessarily match the resolution times, however many bits per pixel we have. It could be different. That's why we have a bytes per scan line value. So really what I should be using is probably Y times bytes per scan line plus X. But right now I'm not going to worry about that till it breaks later. When it breaks later, I'll change it so it works, right? But yeah, change that in this file. Let's just see if stuff still works. I want to be testing things more so I can tell if they break. Nothing should have broken, but just making sure, right? So graphics test does not work anymore, right? Nothing prints. So that's probably an issue. For example, so why does nothing print? Is it because of this? We can probably just point to the base pointer because the base pointer is going to hold the value, right? Okay, so we don't need to be grabbing the 4 bytes at the base pointer and then getting a pointer to that. We can just directly get a pointer to the base pointer now. We don't have to include more indirection. So, because that wouldn't be right anyway. We already have the 32. Here we go. We already have the 32 bits, at this value. I don't have to get, that through more indirection by getting a pointer and then dereferencing that. So I can just get a direct pointer to this. And that'll be okay. So we'll see if that changes anything. Trying to get the graphics test to run again so nothing's broken. Hey, there we go. So we were getting the wrong value. Now we're just directly getting a pointer to the value, so we're good. I press a key and it does not go back, however, that's not good. It should go back immediately. Unless I messed something else up, which I might have, to be honest. In my regular one, okay. Let's see, did I mess something else up? I probably did. After I draw everything, I mean, I just call get key. I'm not sure. I might figure that out later because I have some other changes I want to do with this and not hard code the values. So for the sake of time, I'm just gonna put off that that bug until later. But I'll put it here. This freezes on get key at the end. Find out why. I'll put that as a to-do item. Okay. Okay, so I wanted to change inside of print types, which is not print t, that's not a file, but print types here. I wanted to change some hard-coded values like here. 9028. We can change that now since we have this included in the other files with the graphics header. I can change this to be graphics mode physical base pointer. And only have one level of indirection, not all this other garbage. But we can get a pointer to there. When we change the bits per pixel values, this will change as well from 32, but I'm leaving it right now just for the sake of gradual transitions, right? This 1920 is the X, right? X resolution. It's 9028 is the base pointer again, so this frame buffer can be the same thing. So I'm just going to copy all this. Or the scroll start can be the frame buffer, which is the same thing. We're going to paste it there. And this 1920. It's the X resolution. These values, these magic numbers here are going to have to change as well. Maybe I could do that. This is the bottom of the screen. Okay, let me change these X and Y resolution things first, and then I'll get to that. I also don't like hard coding the font sizes, so those will probably change as well. Font character. I guess while I'm here, I can change that. Make font address. Right now, this is at 6,000. That I could use later for things, maybe. Get rid of that number there. Font address. This is 1920. So this is a bit more typing. It is a bit more verbose, but it is very explicit in what it does. 9028. Okay. And we're getting, I mean, physical base pointer doesn't make too much sense, but it's the, I could rename that later maybe to frame buffer or linear frame buffer, since that's what it is. Maybe that would make more sense. That probably would be a better name at least. But anyway, those are duplicated. Okay, so I'm not using the Y resolution inside of this at all, so, except at the top, I guess. Am I not? I guess I'm not. So 1080 was not hard-coded in here. I mean, that it is in the comments, but okay, well, that's not too bad. So do I have that hard-coded down here for print hex or dec? No? Okay. Okay, so let's see if printing still works, since I changed those values inside of print character. I guess it does not. Undeclared identifier. So I could either include the header inside of the header, or I can move them around inside of the source files. I'm not sure which would be better. This is at the bottom, is why that doesn't work. I'll just put it here. I'll just put it at the top for a second, see if that fixes that. In the kernel, the other ones it won't. That's in the editor, yep, okay. So I'll change that in these as well. This one I'll just put after string. And just to be sure, we'll do that in the calculator as well. Because that is kind of more important than the other things. The other things are dependent on that file to work. These sizes did not change, no, okay. Okay, so that still works, we're still printing things, so that is good. So where do we go from here? Do I have stuff hard-coded, like in the C, like in the kernel and stuff? Do I have 1920? I mean, other than the graphics test, which I'm going to change. 5 thing? No, I don't. Okay. I just want to get basic, you know, hard coding stuff out of the way first. Okay, I don't. All right. So what I can do now is if the user chooses a different X and Y resolution, a different bits per pixel value, we're kind of going to have to change how the colors we use, how those are displayed. They won't necessarily always be 32-bit ARGB color values. So I could work on making that more generic, as well as the frame buffer, since we won't necessarily be in 32 bits per pixel all the time, although modern, machines are. Maybe I want to support older ones, or it's cool having it run different, lesser display modes. Takes up less memory, maybe faster processing and stuff. I will do that, which will be in the print types. Well, it'll be in the graphics file as well, but I'm going to change the frame buffer here. So the frame buffer here, I'm going to change from 32-bit to 8. So this will be a little bit slower, a little bit more processing will be happening, unfortunately. But that's life. I'm going to make it a regular byte pointer because I don't know right now at compile time what the user is going to choose at runtime. Maybe they have a 24 bits per pixel graphics mode. Maybe they have a 16 or 15 bits per pixel, maybe even 8. So I want to support all those. I'm not supporting 4 bits per pixel, unfortunately. Monochrome or grayscale or whatever. I'm setting the line at 8 bits per pixel, VGA 256 color palette, but we'll have a regular byte pointer here instead of a 32-bit, so everywhere that I get 32 bits to set the color, that is going to have to change, as well as these scroll values here. These are going to be byte pointers. That's going to be, instead of 32, we're doing 8. So this stuff is going to have to change a bit, which is unfortunate, but I'm making it more generic. That is all right. This assumes they're 32-bit. This will have to change. Make generic, not 32-bit. Assume. Okay. I'm just putting this here because I'm going to forget if I don't put it here right now. But this will probably break right now and not work because we're not doing full 32 bits anymore. What am I going to do instead? I'll show you in a second. Just want to make sure I don't have frame buffer stuff down here. Okay. So we are still going to add the row and the column. That's fine. This can probably change. So I'm going to get a bytes per pixel value. Let me change these to 8-bit first. I'm going to get a bytes per pixel value instead of assuming a hard-coded 32 bits per pixel value. So I'm going to put that, I don't know, I'll put it after the frame buffer. It's going to be 8 bits. It's going to be bytes per pixel. So this is going to be the graphics mode bits per pixel value, which is inside of here. The VBE info block has a bits per pixel value. That'll say how many bits per pixel the video mode's using. So, 8, 15, 24, 32, whatever. And normally you could just do divide by 8. However, if I want to support, 555 RGB, 15 bits per pixel, then this will not work because 15 divided by 8 for integer division here in C will be 1 and not 2 bytes that it takes up. So I'm just going to add a 1 first, a little hacky solution here. We'll increment that first and then divide by 8. Get number of bytes per pixel, add 1 to fix 15 BPP modes. Because 15 divided by 8 would be 1, but 16 divided by 8 would be 2. So that'll work. If it was 8 bits per pixel, this would be 9 over 8, which would be 1 byte. But this will work. Just the +1 will fix any odd values like 15. 15 is the only odd value really, but that's just a little hack to fix that. But okay, what are we doing with the bytes per pixel value? Well, when we actually write stuff with the colors here, pixel here is sort of a byte value. We're counting double words here, so. But the pixel value here instead of double words can be in terms of bytes. I need the bytes per pixel value. So I can multiply that by however many lines we're moving, right? Actually, I can change this back to 32. I didn't mean to make that an 8-bit. I meant to make that 32. Because this can be up to 32 bits for this value that I'm going to use. So I actually meant to make that 32. Let me change that back. Sorry for being confusing. Not making up my mind. But instead of sort of a pixel value, this is more so however many pixels we're going to draw on the screen. Yeah, but how many bytes are in those pixels is what I want to figure out. So it can go up to, instead of this hard-coded value, we will be using the bytes per pixel value, but this will go up to the Y resolution. multiplied by, we could multiply it by the X resolution. We could, since we're scrolling up by a certain number of lines on the screen, I can say however many bytes are in one of those lines is how much we're going to move, you know, for each line. So the Y resolution is how many pixels wide. So I can take how many lines in the screen we're going to do, which is, it's either bytes per scan line, or since we're in linear frame buffer modes only, I'm not supporting bank switching or anything, I'm going to do the linear bytes per scan line value from this VBE info block, this graphics mode. So that's how many bytes in terms of how many lines we're going to scroll up for this on the screen. So if it's like, I don't know, however big the screen is, 1920 by 1080, it could be up to, you know, 1080 lines. How many bytes are in all of those lines? It'll be, you know, the Y resolution times the bytes per scan line. But what I can do after that is divide by the bytes per pixel to get the number of pixels that we need to move, right? So this could be up to 32 bits because we don't have 64-bit per pixel color modes yet. So if this was 32-bit, this would be divided by 4. And it'd be 4 bytes per pixel. If this was 24 bits per pixel, this would be 3, so it would be 3 bytes per pixel. So it's however many bytes in 1 pixel times however many pixels we need to move in bytes, which is this value, right? So for each one of those pixels, we need however many bytes are in the color that we want to draw on the screen. How many bytes are in the pixel? Because they could be in 24 BPP mode or 15. They're not necessarily in 32 anymore. I'm going to walk through each byte of whatever color we're drawing. Instead of just having it be 4 bytes at a time, it might not be a 32 bits per pixel mode. So I need to work through each byte of the color now. So it'll be slower processing, but that's okay. So I'll have another for loop, unfortunately. There's probably better ways of doing this as well. Maybe a switch or something depending on the BPP instead of doing this, but oh well. I'm going to make it UN8, make it a character. So temp will be 0, temp will be less than bytes per pixel. Temp plus plus. Put that in brackets here. So scroll start, we'll do offset by temp will equal scroll start 2, offset by temp. And then I'll have them both increase by the bytes per pixel value. You could write this more succinctly. I'm just putting this here to hopefully make a little bit more sense. So for each pixel that we're drawing, there will be 32 bits per pixel or 24 bits per pixel or 16, what have you. We need to go through each byte, so each 8 bits in that bits per pixel value to get the right color that we're going to draw. So I need to get, you know, this offset by this to get the right byte within those up to 4 bytes, depending on the bytes per pixel value. Since I'm using 8-bit pointers now for these instead of 32 hard-coded, so just making that a little bit more generic, but it is a lot more processing, unfortunately. But okay, so for each one of those, we want to do this. Maybe to make more sense, I can move the brackets outside of here. That might make more sense. That might actually work better. So for each pixel, I'm going to set all these equal 0 to however many bytes, and then I'm going to increase by that many bytes, and then we're going to do this again. Okay. And this will be the same thing right here. I'm going to get rid of those and this. Instead of 16, this might change later. So last, I'll do font, character, height, lines, some generic thing there, generic name. Okay, so this was predicated on being, what, 16 lines, right? How many pixels do we need to do for this? So for this one, since we're at the last character line, we're assuming the font has a certain height and lines that we're stuck on here. So since I did the 16 up here, I'll put the 16 down here. And I'm going to use the X resolution instead of the Y resolution. Multiply it by that character height. That should be a times. For the single pixel value. And then I'm going to divide that by the bytes per pixel, and we'll do a similar thing, you know, here. This will still be clear last line. Clear last line, get rid of that. So scroll temp will equal our color that we're drawing. So what color are we doing? The background color, text BG color. So This will not necessarily be 32 bits per pixel anymore though, so what I'm going to have to do is offset this by whatever byte we're drawing as part of the color, which probably doesn't make sense. What I can do is shift right by temp, and since this is an 8-bit value, it should, I think, change it to an 8-bit value. Okay, let me just make that explicit. We'll do UN8T. So text background color, shift right by temp. Let's put this all in parentheses to make sure. And I also need to increment this by the bytes per pixel again. Okay, so what is this doing? This is saying, so I'm converting this to an 8-bit so that it fits within this 8-bit pointer value. So offsetting by temp, indexing by temp, which starts at 0. I'm shifting this right by temp and making it an 8-bit value. So if our color right now, it's 32 bits, it'll change. But right now, let's say this is yellow, right? So RNG will be F, B will be blue. So what this is going to do is, first of all, it'll shift right by temp. Temp will start at 0. So it'll just get, and it'll make it an 8-bit value. So shift right by 0, this will be the same value. It's not going to shift right by any amount. Converting it into 8 bits will basically just get the last 2 digits here, 2 hex digits. So the 2 nibbles, the 2 4-bit values. So that'll just put a 0 in for this value here, scroll offset by temp. But after that, temp will be 1. So if we shift right by, so this actually isn't correct, because if we just shift right by 1, we'll basically just take off the last, the last 0, right? We'll be left with this, but that's not correct. So what I actually want to do is shift right by however many bytes we want to get. So shifting right by a byte would be 8. So for example, if we shifted this value by 8, we would get rid of these, and we'd be left with these Fs. So these 2 Fs would then go into scroll, indexed by temp, and then if we shift right by 8 again, we'd get rid of these 2, and then we'd get these Fs into scroll by temp, and then if we shift right again, we'd get rid of these 2 and get the zeros. So that would end up shifting right by 8 4 times for our 32 bits per pixel color value. We're just basically taking that 32 bits and breaking it into 8-bit chunks to put inside of our pixel that we've indexed in the screen here. So, but yeah, and as I just said, this isn't correct. We don't want to shift right by temp, we want to shift right by temp times 8. To get the full 8 bits, the full 1 byte that we're breaking that larger byte chunk into for the pixel color. I said that badly, but you know, if this is 32 bits per pixel, this will shift right basically up to 4 times. And it'll put that color value in little Indian form inside of, you know, our scroll here. But I did not have to do that up here. I just transferred the bytes. But to set the actual color value, I will have to break it up into 1 byte chunks, right? Up to the bits per pixel value. It's translated into bytes per pixel. So I'm hoping that makes sense. I didn't say that really well, but that's what I'm doing there. I will also have to do that down here because I have 2 areas to scroll because I am bad at the dry principle. So we can copy the stuff up here probably, right? Yes, so let me get this. I'm just copying these 4 loops here. For that, so instead of these 2 lines with the 1F2 and this, just get rid of those. Make that a capital, and then copy this over. And then we don't need this other one here. Okay, so that should ensure that scrolling works. It might not work great, so I am going to test that. I shouldn't need to change anything else with these things though. Okay. I don't. So let's make sure scrolling works and that I didn't just lie to you and it doesn't even compile. So that's good. Did you mean bytes per scan line? Is that what I named it? That's probably what I named it here. Yes. All right. Let's make this just scan line as 1 word. Because that's okay. Undeclared identifier scroll to. Really? Oh, I called it scroll start and start to. I mean, these names are shorter, right? I don't know if they make any less sense than they did before. We'll just do that. But that's scroll start. Okay. Let's rename that scroll 2. 1, 2, 3, 4, 5, 6, 7. So that can be 7x. Put it 2. Okay. Where else did I have those scroll things? Yeah, the frame buffer I have to change as well. This is scroll 2. Like troll 2, but not. Scroll 2, okay. Scroll. All right. Oh, it does not like that because I didn't put a bunch of things. Okay. Scroll and scroll. Yeah, that's not good. This needs to have a 2 on there, doesn't it? This needs to have a semicolon. Can I mess up anything else? Yes, I can. Let's get that. Can we mess it up? Yes, we can. Implicit conversion. There we go. So now that's failing, which is good because I put a to do there anyway. So we need to change the frame buffer to get pixel values 1 byte at a time now that we changed it to an 8-byte pointer. So I'm glad that error came up. Okay, so this is going to be a little bit more code. I'm going to do something similar to this, where I'm doing UN8 shift right by the thing. I'm going to do that. Okay, how do I change this? Well, I'm going to change that. This will be an if. And I'll say if the bit is set, we want to draw, you know, the foreground color, else we want to draw the background color. I'll do else. All right. I want to draw the foreground color here. So what I'm going to do is a similar thing I did above. For temp equals 0, temp less than bytes per pixel. Temp plus plus. And then frame buffer indexed by temp. Will be that area of the color. That byte of the color. So UN8T, this will be the foreground color. Shifted right by temp times 8. And then we'll do the same for the background color. Guess I don't need these if I do that. Actually, let's just copy that here. So instead of the foreground, this would be the background because the bit would not be set. Okay, so that'll draw the foreground color or the background color. I'll put these curly braces because that makes more sense here. It reads better. And then frame buffer can be incremented by the bytes per pixel. Value. Okay. So a little bit more code, but that is all right. That should be okay. Hopefully this is all right. I might need to change these by bytes per pixel as well, actually. Our row and column? No, so I'm going to change some more things because I'll have to. Let me see if that got rid of those other errors. It did. Okay. But I have to change some more things, changing a lot of stuff today. So the row and column here assumes sort of 32 bits per pixel. So if we want to make it translated to 8, you know, a byte at a time, we have the Y value times the font height times the X resolution. So I can multiply this by the bytes per pixel value to get that amount in bytes, because that's what we need to move the frame buffer by. It has to move by bytes now. So maybe now you're starting to see why some large projects have a bunch of code, because they have to handle more use cases and be generic, which I'm doing a bad job of, but that's okay. Bytes per pixel, and then this will be correct now. So when we move the frame buffer has to move by a byte value now. It can't just move by a generic 32 bits per pixel. I'm just kind of looking for that now. So like here, X resolution times 16, we need to multiply by bytes per pixel, which is unfortunate. So we had a lot more code to everything. That's all right. So every time the frame buffer moves, it moves by bytes. It moves by bytes. This needs to move by bytes, as well as this. 8 times bytes per pixel. So, you know, for example, to get to the next character, a character is 8 pixels wide. How many bytes are in those 8 pixels? 8 times bytes per pixel. That's why I'm doing this everywhere, if that wasn't fully clear. Anywhere else we're moving the frame buffer? Right here. Okay. That should be all right. We don't move it down here. No way, no how. Okay. All right, so if everything does not print and it looks terrible, it's because I messed up, but I need to change these values first. This is a 1B now, like it was before. So this is 25, 32, and calculators E, editors F, which is fine. So this is back to being 1B. This is 1A, 1B. All right, for about an hour. Okay, so everything should be exactly the same, so a lot of work for like no payoff, right? But the whole point is that it is more generic now. We're writing 1 byte at a time for each pixel, even though you can't appreciate that or see it. That is what is happening when we're drawing text now. It's made more generic. So hopefully we can change the graphics mode, X and Y resolution and bits per pixel, and stuff should still work outside of the colors being different values, right? And I'll get to that next, I think. But just making sure everything, so the editor doesn't load anymore. That's good, actually. That's not good. I broke the editor. Can I load anything? I can load the calculator, but it doesn't print correctly. Okay. Did the calculator increase in size? Calculator 0E, did that go up? Oh, it did go up. Oh, well, that might be why. That went up. That's not good. I'm hoping that was the only reason why. I just misread that. Oh, that was the reason why. Can I load the editor now? I can. Wow, I'm just a big dummy, you know, but you know that. Okay, test file 1 prints the alt, and we're okay. All right, that does work now. Okay, so what am I gonna do now? These colors are in 32 bits. They're hard-coded to 32 bits each. So if we have a bits per pixel value that is lower than 32, these won't necessarily be true in all cases. Nothing will be true for 8 bits per pixel because it doesn't use direct color, like I'm assuming right now. But if we want to work for 15, 16, or 24 bits per pixel values, we'll have to convert these into compatible, you know, values for those lower BPPs. So I'm going to make another function down here to convert a 32-bit per pixel sort of sample color into whatever bits per pixel we're actually drawing or actually using. I'm going to do convert color to set BPP value. I'll just call it that. So since when I'm printing, let me just say this first. Since when I'm printing things, I'm going up to the bytes per pixel value, but this can go up to 32 bits. And right now I'm using 32 bits for these colors anyway. I'm going to assume this is just going to return a 32-bit color. So the return value is going to be uint32. But that will be when it's drawn, you know, this 32 bits will hold whatever converted color value we're actually doing. So if we have a 24-bit per pixel graphics mode, this 32-bit return value from this function will only hold the 24 bits that we're going to draw. Let me write this first, convert color, and it'll take in a 32-bit color. So if we send this function, I'll just put yellow again, FFFF0, just so it's not all Fs and it's harder to read. Actually, let me do 1, 2, 3, 4, 5, 6. If we're in a 24-bit per pixel color mode, we only really, well, we don't care about this. We only want this RGB. So what I'm going to do is, well, this will be the same actually, but if it's 16-bit, it'll only have 16, so on and so forth. But this 32 bits will only hold this number if we're in a 16-bit per pixel, you know, thing. I'm going to do this anyway, because if we're in a lesser bit per pixel graphics mode, the sort of the color space, the amount of colors that is available to be expressed within that graphics mode is going to be lower than the full 32-bit per pixel color space, if that makes sense. You have, I don't know, maybe it was either 24 bits per pixel was like 16 million, or maybe that was 16 bits per pixel. But one of these color modes, you have 16 point whatever million colors available, right? And 32 has however many million colors available. But the lower modes, 15 bits per pixel, 16 bits per pixel, have a lot less colors and shades available than the full 32 bits. It can't express that amount of data, right, in the lesser amount of space. So I also have this function here to convert the full 32-bit color into a sort of lesser color space. It won't be the exact same color, but it'll be pretty close. So I'm trying to get the closest amount here. Like a given shade of gray within a 32-bit per pixel mode will be changed if converted to a 24-bit per pixel mode, because it won't be the same shade of gray. It'll be less data encoded. That's kind of what this function is also going to be used for. So what I'm going to have is sort of original colors and colors that we're changing to. Okay, so continuing onward with this, I need to convert. I'm going to say convert a given 32 bits. It'll be 888 RGB. Can do ARGB, doesn't matter. 888 ARGB color to set bits per pixel. So this will be something like RGB, where each of these are, 4 bits or one nibble of a hex digit. So the red portion of this will be 8 bits, the green portion will be 8, the blue portion will be 8, so that's fine. So what I'm going to do to convert that into a lesser color space, or if we're still in 32-bit, it won't really change it, but to convert that into a lesser color space, something like a 16 or 15-bit color, whatever, I'm going to get the original colors out of this given color that we're sending this function. So I'm going to have orig R, G, and B, standing for the original red, green, and blue. And then to correspond with those into the color that we're converting to, I'm going to call it converted RGB, or maybe convert RGB for the converted red, green, and blue values. And then the final color that I'm going to return, I can make a separate variable, why not? I'll call it the converted color. So to set these original colors, I'll do that first. To set like the original RG and B values, I'm going to set them to the color that was passed in, shifted by some amount. I don't really need to put in parentheses, but that's fine. So for the red portion, if we're given RGB in that order, so this RGB, if we want to extract the R value here, we're going to have to shift this right by, 4, 8, 12, 16. Yeah, that would equal this. It would take off, the right 4 hex nibbles there. So if we get that and we put it into an 8-bit value, that will only extract, the red portion. Although we can explicitly set it as an 8-bit value by, say, ANDing it, bitwise ANDing with FF with 255 so that all the ones are the same. And I'm assuming that would expand that FF into a 32-bit constant as needed. I'm not sure if I really need to do that here, but I can keep it there to be, I guess, extra pedantic there. It's an 8-bit value. But that'll extract the red portion. We can do something similar for the green and blue parts. We just need to shift left by a lesser amount. So if red is 16, because we have to skip these 4 hex nibbles here, green would only be skipping 2, so it would be shifting right by 8, and blue we already have at the given, the start of the number here that we're passing in. So we don't have to shift blue by anything. We can do green by 8, and blue we can just AND it with FF. That will extract those original color portions. So now to get the converted portions for this, say the converted red color, what I need to do is get some percentage, some ratio of this original color that we're getting. So if we're moving into like a 24-bit per pixel from a 32-bit, it'll, the color won't be the exact same because it can't hold as much data. It'll be a lesser version of that color, if you will. It'll be sort of a percentage of the original color because it takes up a percentage of that wider color space, I guess. Okay, so to get a percentage of this, I'm going to multiply by some fraction, some ratio of this whole original color, assuming the full 32-bit, the full 8 bits of color that were passed in. So the full 8 bits of color would be something involving 255, that's the maximum value in 8-bit. number can hold, and that would be corresponding to the full range of colors in our 8 bits per, RGB values. The color mode we're converting to could be lesser bits, could be 565, 5 bits for red, 6 for green, 5 for blue, could be 555, could be some weird other thing that we don't know about. And that's within our struct, which we have at the top because we copied that over. That's within these linear red, green, and blue mask and field positions I talked about a long time ago. So we can use those as part of this. We have to use that some way, but I'll just put that here. The linear red mask position. Or the mask size, sorry. I'm trying to combine them in my head. The red mask size. I'll have 255 over here. And that corresponds to how many bits of color that this red corresponds to in whatever graphics mode we're in. So if this is a 5, if this equals 5, we have 5 bits of red in whatever color we're doing, whatever pixel we're going to draw later. So I need some way of converting the original color to this color. I'm using the red mask size. The original color is assumed to be 8 bits for red. This is assumed to be whatever this is. It might be 5 or something else. But to convert the original 8-bit to this lesser bit, if it is lesser bit, what I'm going to do is shift 1 by the mask size. Oh, and this needs to be graphics mode with an arrow. Okay, and if I do that, I get sort of 2 to whatever this power is. If this is 5, this will be 32. Calculator here. Okay, we can do deck is fine. 1 shift left. Let's say we have 5 bits for the red. That's 32, right? Yeah. But I'm going to have to subtract 1 from this to get a 31. Then I'm going to have to divide by 255, but since these are integer values, I'm going to make it a float comparison, and then when we multiply back, it'll convert to an integer for the final value. So 3 parentheses here. Okay, and that would convert the color here. So why does this work? Let's say red is 5 bits instead of 8 bits. 8 bits would be FF. Say we're converting a white color. If red was 5 bits, then we have to shift that right by 3. We only have 5 bits of color here, so that's 31. Right, so we're assuming a percentage of the full space. The highest, the maximum value that an 8-bit number can hold is 255. The highest, the maximum value that a 5-bit number can hold is 31. So that's why I'm subtracting 1 here. If we didn't do that, we'd have 32, and that's 1 over. It's not really correct. That would count it as the sort of 6-bit number, sort of. Yeah, so that's why we subtract that. We divide by the 255 to get the percentage of the complete color space we're converting from, which is 32-bit. This gets like, say, if we have 5 bits of red, this gets the proportion of, 5 bits fitting into the 8-bit space. Or not really fitting into, it's converting 8-bit to 5-bit in this case, but it's converting to whatever the bits that the mask size is representing. If this is 5, it'll convert 8-bit to 5-bit. If this is 3 for whatever reason, it would be, an even smaller number because it's converting to 3. The reason I'm doing a 0.0 for float is because we're doing integer arithmetic here with the uints. So if I just did 31 divided by 255, it's going to be 0. I mean, we can take the remainder, so maybe I want to do that. But if we just do a regular 31 by 255, we make it a float, it'll be something like this. Although the precision will be less, I don't know, maybe it's like this high, but we multiply that by the original value. So let's say, if it's white, it would be FF, so it'd be 255, it'd just be 31. But if it's not white, if it's some lesser color, maybe it's like a gray, a deep gray or something, which 22 in hex would be 34. So let's get that back. 31 divided by 255. That's the ratio, the lesser bits of color to the full bits of color. Then we want to get our original color to convert that into this ratio. So let's say 34, which in hex would be 22. We'll say it's a deep gray. That'd be 4. And that would be our converted R. So if we had 4, it would be over here. Instead of, we'll say 2, 2, we're losing that precision. But anyway, that probably doesn't make too much sense, but that is kind of how it works. We can do the same for the greens and the blues, because they will have their own mask sizes and field positions. So instead of red mask size for green, we'll do green mask size. And blue, we'll do blue mask size. And you know, if it's 565, this will be the 6 bits of color. These would both be 5 bits of color, and they would be converted from 8 bits into their lesser bit numbers. But similar color representations. The color on screen will look pretty similar to our original color were we in a 32-bit color space. So now that we have that, we can get the new color that we have. I'll say put new color, we'll do portions, since I'm calling it portions for some reason. Ratios, percentage, portion. In my mind, they all mean similar things. Put new color portions into new color. So this is where instead of the mask sizes, this is where the field positions come into play. So what we can do is take our new color and we'll shift it left by their field position. So that'll be linear red field position. That's what I called it. We can build this up like flags, like bitwise flags. So I can OR the red with the green with the blue. This will be ORed as well. This will be it. So the field position corresponds to what bit within the color that the field is. So this will work. If we do it this way, it'll work for RGB or BGR or GRB, you know, whatever order the red, green, and blue is within the color. So for this given 32-bit 888 ARGB color, say, the mask size for each of these would be 8, because they're all 8 bits in size. The field position for the blue would be 0. It's at position bit 0 in the color. The field position for green in this color would be 8, because they all take up 8 bits. B would be 0 to 7. G would be 8 to 15. R would be 16 to 23, right? So B, the size is 8. The field position is 0. G, the size is 8. The field position is 8. R, the size is 8. The field position would be 16. Or if we count from 0, R would be 15, not 16 rather, because G would be 8 to 15. So R, the field position would be 15 here. If we have a 24-bit color, if it's 888, it'd be the same. Let's say we have if we have a 565 16-bit color, then B, the mask size would be 5, the field position is 0. For the green portion, the mask size would be 6, the field position would be, I need to count these things out. B would be 0 to 4. Keep forgetting 0-based stuff. G would be 5 to 10. No, it would be 5 to 10. And R would be 11 to 15. Yeah, that's how a 16 bits per pixel 565 would work. So the field position for B is 0. The field position for green would be 5. The field position for R would be 11. And the mask sizes would be 5, 6, and 5. That's what I'm trying to say. And these need to be converted. This needs to be G and B. This needs to be green, and this needs to be blue. Okay, and that will give us our final color. So if we're using a 32-bit per pixel color mode, then if I convert, it'll stay the exact same, because this would be 8 minus 1 would be 7, but the maximum value that we're going to get out of this is going to be the same. It'll be 255 divided by 255, which would be 1 times the original color, so it would be a full proportion of that original 8-bit color. But if we have a 24-bit color space, these will actually still be the same, I think. 16-bit color space will be different because it'll be 565, so these will be lesser numbers. And 15-bit, the green would be less, so... Okay, 8-bit, however, will work differently because in my VBE modes here, in qemu, and I think in bochs as well, the 8-bit color modes that you might choose, 640 by 480 8-bit or 800 by 600 8-bit, they use the VGA color palette, the 256 color palette. They don't use direct color like these are using. So if you use an 8-bit per pixel VBIOS extension mode, which I guess because it's compatible with the old VGA or whatever, these mask sizes and field positions will be 0 that are set up. They won't be set. So I'm going to do something a little bit differently for 8-bit. I'm just putting it here because I can use it later. So if the bits per pixel is 8, Let's put 8 bits per pixel uses, I don't know if it's standard, but I'll put standard. Standard VGA color palette. And what I'm going to do for this, to be lazy, is saying whatever value the user enters, I'm only going to consider sort of the last 8 bits, or just if they only enter 8 bits, then it'll be 8 bits. I'll have a thing to enter colors in a bit, but I'm saying bits a lot. I'm going to have the user enter a color later for a command, and then we can convert it, right? I'll do that in a while. I'm assuming that's already made here. But I'll do user can enter, I'll just say any 8-bit value for color. We'll put in 0 to FF, we'll say, and it'll just use that as an index into, the color palette. So how am I going to make that work with my code down here so I don't have to change more things? I'm just going to set R to 0 and G to 0. So convert R, convert G, convert B, I'm going to set to the original. Just so if they enter something like FF, it'll, correspond to white. Well, it'll be black because it's the VGA color palette. 255 is black, but 15, a singular F, would be white. So that'll work. They can basically enter whatever on the VGA colors. We'll do something with that in a bit, but this is all I'm going to do for, converting a color between different bits per pixel, between different color spaces, I guess. For lack of better words there, but yeah, it's not too bad. This needs a parenthesis. And this color doesn't really need that. Okay, and that should work. Of course, we're not using it yet, so you can't see that it does work, but that should work. It should at least compile. And I lied because it doesn't. Control reaches end of non-void function. Yes, because I'm not returning anything. Sorry, I want to return the converted color. That was the whole point. Or what I can do is just put it as the original color value and not return a separate variable. That might work as well. But we'll just return that for now. Okay, the other things were, I had some issues with the graphics test function, right? Because I didn't change all the frame buffer values and everything. So this frame buffer here in drop pixel is 32. We need to make that 8. I'm going to change these to be like the print files, print functions. Rather, the new one, where I get everything sort of 8 bits at a time down here, sort of like this, according to whatever color we pass in. So here where we set the color, instead of doing this, we set this, we need to get the bytes per pixel value as well. I can set that up here maybe, and then I don't have to include it in other files. That might be good, actually. But this is at runtime, so I can't set that as a global variable like in this graphics header, because it would need a constant to be at compile time. So never mind, I can just set it within these functions. That's okay. A bit unfortunate, but that's okay. We'll have, so y times the resolution plus x, I'll multiply that by bytes per pixel. Okay, so for temp 0 to bytes per pixel plus plus, this will be uint8, whatever color we're doing, which is passed in, shift right, never mind, shift right by temp times 8, yes. That'll get 0, then shift right by 8, then 16, so on. And that'll set that color for that pixel, so that's okay. Should be okay, we'll see in a bit. The issue was with the fill functions. So not the draw ones, boundary fill. So all these that call boundary fill. Because these, well, this doesn't need to be that anymore. We just need to get the pointer to the actual thing. Times bytes per pixel. Let me grab that. Okay. Alright, so to fix this boundary fill thing, now that I changed these and got frame buffer start position, I need to check if the colors are equal and then fill it with those colors. So I have to change this check first off. I'm going to change that a little bit. This is not really efficient and I should write this better, but I did not, so keep that in mind. This could probably be written a bit better. But I'm going to have a similar thing to check the color as I do to set the color. So just temp less than, the bytes per pixel in a loop here. So I'm going to check if the frame buffer value at temp is equal or not. So I'll do not equal whatever color we're checking. I guess both. Yeah, we're checking both down here, the boundary color and the fill color. Okay. So check it compared to the fill color. This is going to be over here. It needs to be shifted right by temp times 8. And I know in all of these places where I'm doing division and multiplying by like a power of 2, like divided by 8, instead I could do shift right by 3. I know I'm not doing that right now. I might change that later, but this is just for it to make more sense because we're working in bytes at a time. Makes a little bit more clarity here. We're doing that. So this color here, so frame buffer is there, okay. So I want to do a similar thing to check against the boundary color. So instead of fill color, this will be boundary color. Okay. Now we need another one for that. So if those are all true, I'm not a fancy Lisp programmer, I'm going to set a little flag called draw, just set it equal to 1, and get out of the loop. Otherwise we'll be going through all the bytes per pixel. If any byte of the color is not equal to that corresponding byte wherever we're looking at, then we don't need to check all of the bytes, so I'll just break out at that point. But if they all match, then I don't want to actually draw the color, so that's why I'm setting a flag here, so that we can check the outcome of all of these being checked if need be. So I'll set draw equal to 0, okay. And then down here, that takes care of that check with that if loop. We can do if draw, then we can draw the pixels. Same thing. Same loop here to actually draw the color, go through each byte of the color, is what this is going to do. So frame buffer temp will equal the U8T of what color we're filling in with, the fill color, shifted right by temp times 8. Okay, and then to check the 4 pixels around the current one, this will still work. So all we had to do was break out checking each byte of the color first, and then writing each byte of the color. And I think that will take care of the filling things being issues here. I don't think I'm using the frame buffer anywhere else. Just gonna make sure, only in those 2 functions. Yeah, okay. And I made a bad no there. So where is that? Okay, so what did I mess up here? I missed an ending bracket or something. Oh, I need one there for the if. Yeah, need a corresponding one for the if. Okay. That was all that mattered. So now I need to increase these stupid file sizes again. So they all increased by 1. Kernel goes to 1C, calculator goes to F, editor goes to 2.0. Yeah, all increased by 1. Okay. That's not bad. That'll be 2.6, 3.4. That'll be F, which makes that 3.5. And this is 2.0, which doesn't need to change. Bootsex. It's now 1C for the kernel, which is too far. There we go. So that's B, C, BC before comedy. Alright, so let's see if everything breaks. It should work the exact same as it has been. Same as it ever was. Everything still prints out. Although now for draw pixel, it'll be 1 byte at a time for the colors. The graphics test does now work, and it was probably optimized by the compilers, why it's not super slow, even though I wrote it to be a lot slower. But this now works. We press a key and we go back, so that's not broken anymore, which is really good. I'm just going to see how scrolling works here, because I haven't looked at that yet. So just print a bunch of stuff. Okay, scrolling is unbearably slow, and we have issues there. So that's good to know. That scrolling is messed up. That's good to know. So we do need to fix that eventually, of course. Is it something I messed up? Probably. Okay, so I think I found the issue with scrolling. It is where I'm setting the scroll to, the end length where we want to scroll to. I did make scroll and scroll to here byte pointers, but I'm not using the bytes per pixel. So I think I have to multiply this by bytes per pixel. Otherwise, it's not taking that into account. It's not 32-bit anymore. I need the number of bytes we want to scroll, in which case I have to scale it by the bytes per pixel here to know how far down one character row is on the screen, other than xres times 16. This is, you know, not how many bytes we're doing. If it's 32-bit mode, this would be off by a factor of 4, and it would be scrunched up 4 times, which I think was what was happening. I'm not sure. So I'm going to scale that down where we have the scroll to values. I'm hoping this is the only thing that needs changed. We'll find out. Yeah, okay. Although since I'm recording and I got this, you know, within an emulator, within a VM, within, you know, whatever. Scrolling will probably be very slow, especially since I'm making it slower. What, editor went back to 1F? Why has it got to do that? What are you doing? It decided to save space somewhere, that's fine. Just in case I want to test it, which I probably don't. Well, let's see. Okay, so the lines are being printed correctly. However, the colors are not being printed correctly, obviously. That still needs, well, it's got stripes in there. We don't really want the stripes in there. That's not good. That should be where I'm setting this. Whereas times bytes per scan line divided by bytes per pixel. Okay, so one other thing I could try is here. One other thing I could try is here with the Y resolution times the bytes per scan line. I can subtract from the Y resolution whatever the height of our font is. Here's 16. And then we set this. So that would, you know, leave the bottom line of the screen, and then we'll fill in the bottom line of the screen here. I'm not sure why exactly that would mess it up, but that is something I had changed when I was testing. So I'm going to see if that changes anything. It might not, but we'll see. Okay, that was the issue. So I was getting like, I guess maybe past the bottom of the screen, which data was not set, so it would all be black, and that's why it was reading, you know, basically nulls or whatever for the color that didn't exist there because it was beyond the edge of the screen and we didn't put data there to read from. We're only reading inside of the screen, we're not rendering anything outside, if that makes sense. So by setting that to be minus 16, we actually set it to before this line, and then we fill in that line with the color. Okay. I guess that makes it work. The clear screen and the cursor commands, those will have to change. So let's go ahead and do that. It'd be in screen, and it would be clear screen, because this is still using a 32-bit frame buffer pointer that we don't need anymore. Don't need that. Well, that we're not using. We could still use it, but we can change this. This would be the physical base pointer. And these will change. 1920 will be the X resolution. 1080 will be the Y resolution. That's however many pixels are in the screen. So for each pixel, we want to write the color, right? Yes. So this will be a double for loop, unfortunately. I could use I or J, or I guess I'll keep using temp just to keep it consistent. And I need a bytes per pixel value as well if I want to do this. Would be here, bytes per pixel. Which will be the bits per pixel. Plus 1 divided by 8. Okay. For all those, frame buffer temp. going to be converted to an 8-bit. The color shifted right by temp times 8. Okay. So let's see if clear screen works after doing that. And editor rose again, of course it did. So let's just write, oh, that doesn't work anymore. So clear screen doesn't work, never mind. All right, so this is wrong, that's good to know. Oh. After I do that, oh, let's put this out here, that works better. That's how it actually works. Okay, after I do set the color, I need to increment the frame buffer by the bytes per pixel. Yeah. Otherwise, it's just setting the same thing. The frame buffer never goes anywhere. It just sets the first pixel again and again. So yeah, that would be good. That would be good. So set it and then increment it. Set it and forget it. There we go. Okay, it's just slow, which makes sense because we did a lot slower processing, but so it is slow. Scrolling is slower now too, but we're moving a lot of data at once, but that's clear screen. So the other thing would be cursor. The other thing would be cursor, because that deals with the frame buffer, of course. Fiscal base pointer, bytes per scan line. We already have that available with linear bytes per scan line by directly calling it from, well, directly accessing it from the graphics mode structs. We don't need that. Cursor X, this will be the X resolution. And if we add it down here, then I might as well scale it by the bytes per pixel, or I could just scale where we actually add it to the frame buffer instead of doing it twice here, but oh well. I already started. Sunk cost fallacy. Okay, font character. I could set it up here, doesn't matter. I don't like having too many, can't type. I don't like having too many numbers that don't mean anything, so we'll do that. The 1920 again. The X resolution. This will have to change. Maybe I could move these things into like setting a color here. It can move into its own function instead of copying it everywhere. That would probably be useful. That's something I need to keep in mind. That would reduce me typing the same thing 5,000 times, right? As well as the bytes per pixel every time that I need. Bytes needs an S. All right, we'll do that. Do similar how I did before in the print types file. Just this will be the foreground or the background. Temp times 8. And then we will have to increment to the next position. This will be equal bytes per pixel. Else this will be the background color. Okay, duplicated code, always good. Not ever good actually. Can I press a B? Is that allowed? There we go. Hands are not cooperating today. Do I need a success return from this? I'm not sure I do. Not sure I do. It'll return when it reaches the end. And we'll do similar things for remove cursor, I guess. Okay. Row and column as well. Just copy and pasting because I don't want to, you know, type too much. Okay. X resolution times 15. We need to add that by bytes per pixel. Scale it by bytes per pixel. Otherwise, it's only 1 byte at a time. We don't want to do that. That would be bad. Okay, and then to set this, we'll do again the temp. Background color. Okay, yeah, that'll work. And then again, this I'm not really checking return values from this, so that should be fine. That should be all right. Okay. So the cursor should now work exactly the same, even though I changed that. It does take up more space though. Calculator is 10, 0f, which is 16, so that's 16. Okay. Let's see, the cursor still moves okay with back and forward space, and that works. Although when we press enter, it does not erase the cursor, so I guess that's wrong. But the cursor should still be working. I don't think it is. Okay. Yeah, I'm not doing what I forgot to do earlier as well. Yep. I'm not incrementing by the bytes per pixel. That's the whole reason I have that there. And I'm not even paying attention to it. For each one of these, need to do that and then increment. Okay. So let's put these curly braces around there. Put that there. Identify the lexical scope that that's happening at. That's fancy words for you. So now when we press enter, it should actually remove the cursor on the end. There we go. So if we do something like calculator, we enter, it removes it. Cool. Okay, so what am I going to do next? Since we're not actually changing the colors, everything works exactly the same, even though it's been like 2 hours. What am I actually leading up to, if anything? I'm going to put another struct here in the graphics header. That's going to hold, right now it's not going to hold much. Type def struct. I'm going to call it user graphics info. I guess. I don't really know a good name for that. I'm going to put the fore and background colors that we're using. I'm going to put that in here, but later on maybe I'll include other things. So for lack of a better word for this struct, I'm going to call it user graphics info. I'll do T. This one I don't care about being packed or not. It'll just hold, you know, values. But I'm going to hold in whatever the current foreground or text color that we're doing is. I'm going to call it foreground color. And then also whatever background color we're using. I mean, I could call it user graphics info. That's a little wordy and it's not a great name for it, but that's okay. I don't know good names for things, you know? Where do I want to stick this at in memory? Well, the VBE info address is at 9,000. That takes up 256 bytes, which is 100 in hex. So we could put it right after that, or just to make it an easier number to remember and still have enough room for things. So I call it graphics in, well, I did FX, right? So let's do that. Make it easier to remember and stuff. I'm going to put it at 9200. So 512 bytes after the VBE mode info address. Put that define up here so we can put it over here. And we can add more stuff to that later. We don't have to change the address unless, you know, we have to. Okay, so what am I doing with that? Well, in the kernel, where we do stuff, like where we clear screen and do other things, I'm going to use those colors instead so they can be user changeable, right? So that's kind of what I want to do here. So in the initial setup, I'm going to set the initial colors as well. So maybe you don't want, you know, the searing white on blue Turbo Borland developer colors. So you don't want those seared into your retina anymore. It's been like 30-something episodes, dude. Come on. I can change them now, or you can change them now. If I actually use them in here, like the clear screen, we'll change this to use a generic user graphics info background color. Instead of just blue, it'll be the background color that will send to clear screen. So since we changed the frame buffer and stuff and these other functions, we don't have to change them to use whatever generic color because we're already just passing them whatever, you know, 32-bit color we're going to use. We just have to make sure we now use this color that's in this memory location in this structure so it can be changed by whatever wants to change it. I'll set the foreground as well. The default, I'm going to use the convert color function. So we don't have to specify, you know, what bits per pixel, what graphics mode we're using. It'll be converted automatically. But I'm going to convert a generic, you know, bright white. It'll be all E's, a very light gray. And the background color, I mean, I like my Grove box and stuff, or Groove box. I used to like Solarize, but it's hard to see for other people. This is more contrasty. So I'm going to put in like a dark gray, all 2s or all 3s or something. So that'll be, you know, light gray on dark gray, but it'll look a little less retina searing than the white on blue. But we'll try this. If we're going to use an 8-bit later, if somebody wants to mess with 8-bit colors, these will not work because it uses the VGA color palette. So what I'm going to do is check that here. Basically, if it's above 8, I'm going to convert these. I'm assuming it is 8. I know this technically could work for 4 bits per pixel, but it won't really work unless I convert it to 16 colors at a time. I guess if you enter that, it would, but... Well, light gray would be what, 8? In the VGA color palette, it's 8, like the first 16 colors, and then dark, well, we could just have black. I can make it terminal. I mean, I work in a green screen for my work, so I could do that. Just make it a green screen. Green on black. We'll try that. Enter the matrix, you know? Is palette 1 or 2 E's? I think it's, or T's. L's. What am I talking about? Is that how you spell palette? With an extra E on the end? Because that looks like too much, or is it like that? I don't remember. I'm not going to Google it right now. But everywhere where we have clear screen or we're using colors, I'm going to have to use this new, you know, background color. So I'm just going to put that here. This one I can change. We're doing light gray. I can pass it the result of converting a light gray color. Yeah, I can do that. Convert color, light gray. What did I set to light gray? All D's. Well, I can still do that then. Yeah, we'll just convert it. There we go. So it'll be converted. Hey, this doesn't freeze anymore. I found that issue, fixed it. I will have to change these 1920 and 1080s, right? Because those are hard-coded for 1920 by 1080. That I might change later. But all these other colors I can just convert. Add a wrapper to them, if you will. Wonder if I can do that in a macro, because that's going to take me a while. But I'm just going to convert all these, and then we'll see if it looks the exact same, because it should, because we're in 32-bit per pixel mode, right? Let's record a macro. Convert, color, escape, go over here, do that, Q. Okay. Or did I make it A? Oh, that only does that. Oh, dang it. Okay, let's do this again. Go to the end of the word, press an A for append, and then do that. Then press Q. Okay. That should work. If I do at A, there we go. I'm all the way up here. Okay. We can do add at. Oh, this is not going to work though, because I'm messing with it. Add that. I do like vim macros. I don't use them enough, but they are very useful. Just doing a double @ sign to rerun the last macro. If I do that and then do a dot, no, it doesn't do it. So macros are different. I have to do add @ that's okay. I would like the dot to also work for that, because that's the last command I ran, but that's okay. Convert color blue. Alright, so that should look the exact same, but I didn't change the other clear screens. Like this one. My macro still stays, that's awesome. That is the last one there, okay. So I will have to change those in the other source files as well. Did you mean info space, is that, oh I did into, yeah that's not right. Definitely not right, F. Expected expression, because I didn't do anything, apparently. What do you mean expected expression? Oh, I did 3 S's. I can't type anything, man, jeez. Well, I can, but I type too much. Too many typos. That should be correct, though. Is that not correct? User graphics info, user graphics into. There we go. Jeez. Okay, kernel is 1D now. The other ones are 20 and 10. That's okay. 277. Okay, I should also look into how to do incremental builds, because I don't need to rebuild everything if only one file changed. Okay, there we go. So the screen did change down here. Now the print functions aren't changed for the colors, which is why that's still blue and white. Oh, so I need to change those. Print types. These colors we're not going to use anymore. Let's just get rid of those. So where do I have text background color? This I need to change. User graphics info background color, right? 1, 2, 3, 4, 5. Okay. Which is down here. User GFX info. Hopefully I didn't put into, but I might have. Foreground color. And the background color. And once again down here. The background color. Okay. Yeah, nothing else should be using those. Am I using them in the cursor? Probably. Yeah, get rid of those. Change them in here as well. Not found, okay. All right, there we go. Now the colors are changed. So that is a light gray on side of a dark gray. Hopefully that's easier to see, or maybe better on your eyes if you're watching these at night or something than the searing blue on white. But we can also go back to that if you want, or you can set whatever initial colors you want here. It's probably still changed within the calculator and editor. It is okay. So let me change those as well to not have them be hard-coded. Do I have blue anywhere? Yeah, there we go. I mean, we could have it be blue, but I'm just going to have it be... I should do convert color as well. Over here. Or what I can do is convert it when we're in clear screen. I don't know, but we might want to set it by default if somebody wants to do that. So I'll have it be converted, but this will be the background color that the user has set. Or that we set for the user. Editor might need more changes, I'm not sure. It might not. Do we have text background? No. Okay, we do have blue. So that is okay. There is more typing involved, but stuff is more generic, so. Copy that. Put it there, not there. Put it there. And just go everywhere where we have these, which I have clear screen in a lot of places, which is okay. And not too many. All right. All these functions should still work, as well as these. Okay, clear screen when we go back is not. That's not good. It's probably in the kernel somewhere. Okay, that still prints. Test file. So when we go back to the kernel, we have an extra one that we're missing, but that's okay. It does print everything out as it should be. So where in the kernel is that? Is that after? Oh yeah, I'm converting the blue, yep. We'll just, around line 526 here, clear the screen before going back. I need to change that. Do I have blue anywhere else other than there? That's fine, okay. Let me just make sure the graphics test works one more time. And it converts all right. Okay, cool. I keep missing. Oh, I keep missing spots. That should be the last one. Fingers crossed, I keep saying that. This one should be the last one. Any day now, there we go. And we go back. Okay, cool. Okay, so I put in that function, or I put in the graphics struct, you know, for the user info for the foreground and background colors. Okay, so before I allow changing the whole graphics mode, I'm gonna make a little function to change the colors now that we have that functionality. All right, let's make a command to change the colors so the user can change it at runtime here. Let's put it below this. Eventually, I don't want to have all these things taking up space, right? I'll just make them constants when we actually use them, but that is all right. This can be change colors, for lack of a better word. This will be change current foreground, background colors. So I'll go down here, wherever we have all the functions, or all the commands. Need to change the graphics test one in a bit. Physical memory map. Okay, so below here, we'll do it. Put that there. Compare it to change colors. And change colors, is that what I called it? Probably just called it change colors, right? Well, I didn't change the command part. And change colors, there we go. And we'll put it there. Okay, so we want to input and change the foreground and background colors. So what I'm going to do for that is I'm going to hold temporary values for those and then change them at the end. I'm going to have a temporary foreground and background color. And this will work because the user graphics info, FG and BG, are defined within that sort of namespace, not within this one, so we can name these the same thing. That's always good. I'm going to print out a couple strings here. Kernel cursor Y. I'm going to print out what we currently have just so they can compare, so you can compare when you call this. Let's make it XA, XD. Or zeros, makes it more explicit. These are 1 bytes. I'm going to say the current colors, which are in 32 bits per pixel ARGB order. We'll do that. I'm going to have foreground color. So foreground. Have a space. Then we'll do print hex. And I'll print the user graphics info foreground color. And we'll do the same for the background. BACK, there we go. Background color. Okay. Then I'm going to have whatever they want the new colors to be. So I'll do new foreground color. We're going to have this be in, they'll just have to enter the RGB values. I'm not handling alpha channels or anything, so we're not going to worry about that. They can just input the RGB, and that'll work with what we currently have set up, so that's fine. If it's 8-bit, we probably just want to enter in the other thing though. So I'll do this. If graphics mode bits per pixel above 8, we'll enter in that. Else, we'll just enter in, I don't know, XX or, well, that's hard to read, NN. So if they have it at 8 bits per pixel and it's like FF, which is a max, which will be black, but we'll just, for argument's sake, FF. When it goes to print out the hex, it'll only print out FF, so that should still display correctly. Because it'll shift it over by a couple nibbles, it'll be 0, it'll stop printing at that point, so that's fine. That should be okay, so we'll have them enter in the new colors here. And I'll move the cursor to do that. Kernel cursor X and Y. So what I'm going to do is get input from the user. So while input character equals get key, while that is not equal to the enter key, which would be 0D, which I probably should make a define and not have it be magic number here, that's okay. So while we're not at a carriage return, while they haven't hit enter yet, they're going to be putting in, I'm assuming to be hex digits between 0 to F. So I'm just going to put in cases for that here. So if the input character is lowercase, I'm going to convert it to uppercase. I'm just putting that here because I don't have two upper, two lower functions or anything made yet in my standard library. We'll do that here. So we'll subtract 30 or 32. 32, right? Yeah, 20. Convert lowercase to uppercase. It needs to be between A and F, not A and Z. Because it's hex, A and F. There we go. And then I can print the character. The input character. And move the cursor after. Okay, and then the character they entered, I'm going to have to convert it and add it to whatever we're currently doing, right? Yeah, I'm going to have to add it as an integer to whatever character I'm going to currently hold within these temporary variables. So foreground color, to get the next hex digit for ultimate color, I'm going to multiply by 16 because hex is base 16. And then I'm going to put in what integer we're doing according to what place within the hex number we're at. So if they enter in, I don't know, what color do they want? Like, all 2s for the gray or whatever. So that's 6 2s. Yeah. So the first one is, I mean, they're all 2s. Let's do 1, 2, 3, 4, 5, 6. The first one will be the 6 here. I'm going to multiply this color by 16. It'll start at 0, which I'm not doing. Need to start it at 0. So it'll equal 0, and then we're going to add in a 6. And then for the next one, we'll multiply by 16. And then we're going to add in the 5, right? Or whatever we're doing. So it'll end up, constructing this hex number back to front here. As long as we multiply by 16 first. If it was a decimal number, we can multiply by 10 first, assuming we're clamped to the range 0 to 9 in the digits instead of A to F. If it was binary, it'd be multiplied by 2 and then add the 1 or the 0, converting to different bases. But we can do this. This is easy enough. So if we're greater than 0 and less than 9, so the isDigit function that I don't have, then we can add in the character minus the 0 to just convert it. You know, convert ASCII number to integer. Do else if it's A to F. What we can do is add, so I can add the first one and then subtract, is it 10? Yeah, or add 10, sorry. We'll add 10. Since the ASCII A starts at, I think, 65, right? It's minus A, not add A. I was like, what am I doing? If they input an A, that would be 10. Well, sorry, if they input a capital A, in hexadecimal it's 10, but in the ASCII, you know, integer conversion, this would be 65. So what I need to do is subtract that 65 to get 0, and then we add 10 to get the 10. If this was an F, F is 15. The capital F would be 70, subtracting 65 would be 5, and then we add 10 to get 15, which would be the correct value for F. That's a 2-liner if we put it all in one line, so that's all right. Okay, so that's the first while loop, then we need to get the second. So I'm just going to copy this whole thing here. That's for the foreground color. We need to get the background color now. So we'll have new background. If it's 8-bit or not, and we'll enter it into the background color instead. That should be okay. And then after we've entered in the foreground and background color, foreground color, and this will be background color, then we need to put them in the graphics struct, which is just setting those values equal. But the cursor would stay on the screen because I moved it, so I'm going to remove the cursor first. Doing remove cursor, okay, but we'll enter in the stuff here, user graphics info, dereference the arrow, foreground color will equal foreground color. You can rewrite this to not need, you know, these extra variables, just directly set it. I know I could do that and I'm not doing it, but I could do that later as a refactor. Make it simpler and less lines of code if need be, but we'll just set the colors here. And then I'll print a new line after we're done, or else we'll still be stuck on the end of the line, I think. So it'll just look a little cleaner if we do an extra new line. Change in double quotes, get rid of that. Okay. And then I think we're done. So we're just entering in new hexadecimal digits for the colors, and then we're setting those colors. So unless we do a clear screen, it'll only change when we type new stuff, but I can at least see if that kind of works here. By changing the size again, it's 1F, so it increased by 2, because it's a lot more code. 2929, or 39. So this will be 1 minus, which will be E, this will be F. Where my mouse is over there, okay. So if we go to change the colors, like say we want it to be, I have to do the capital. So we want to change the colors. We have the current colors, 32 bits per pixel ARGB, are all E's and all 2's. So let's say the new foreground color, I want it to be, well, I don't enter in the 0x. I guess I could put that by default to make it a little easier, but we'll make it yellow because we're in 32 bits per pixel. The background will be, I need to remove the cursor there as well. The background we can have be blue. So 0 and F's. And that did not work, which is to be expected, really. Oh, that didn't work. The blue did, but the foreground did not, because that's not working. Okay. So the foreground color I messed up. Okay, that's all right. New foreground color. Let's put the 0x there so it looks a little better. So when they type out the number, it'll already have the 0x. That would look a little bit better, wouldn't it? And when they enter this in, I need to remove the cursor. Remove. And we remove it after, okay. Oh, I'm doing it both background color. I can't read. My God. These need to be... Well, these do need to be background. This needs to be background. Right there, you dork. The foreground color needs to be foreground, yes. Otherwise I was setting the background color equal to, and that would not work, no. Okay, yeah, that was a little typo, which could change things. Could change things massively, in a bad way, a way we don't want to change. Okay, there's the 0x, so let's change it to red, green, blue, and red, green, blue. There we go. So now it should be, it's a little hard to read with the black, maybe your eyes are better, or my screen's bad. But it should be yellow on blue. But I guess to really see that, I can enter that in explicitly. And then we can see with the same, you know, the two F's for red and green. If I'm on a black background, you can see it more clearly. It's you know, yellow on black. And then clear screen is not working for that. That's interesting. Clear screen is still blue. Am I not setting that correctly? Oh, I'm only setting it the blue in here. Yeah, this needs to be... That would be why. User graphics info background color. There we go. But now the user can change the color at runtime. Isn't that nice? Except I need the capital C. And we clear it, and we're yellow. Isn't that cool? You can change the colors to whatever you want as long as it fits within the 32-bit color space, right? You can put whatever you want. If we want our original colors back, then we can put in, you know, that, and we can get close to the original colors. So that's cool. We can change those now. I want to make sure the other stuff works as well. If we change it, it should, but I just want to make sure. All right, if we do... It's still in yellow in the calculator and the editor. That's all. I just want to make sure. And it is. Okay. The return. There we go. Test file 1 is an RFF. It doesn't know what to do. There we go. Let's make sure it loads. Yep. And it's in yellow. Okay, cool. Okay, let's just ensure the 8-bit stuff worked before I go and make you able to change it here in the bootloader. I'm just going to change these hard-coded values right quick. Instead of 1920 by 1080, 32 bits per pixel, I'm going to do 800 by 600 and 8 bits per pixel, because I know that is one that works, because I've tested with it. 640 by 480 also works, but, excuse me, this should still work. Of course, I don't see anything, so maybe it's frozen. Did I set things to be bad? I mean, I'm converting 2 and I'm converting 0. So it could be that these are not working here. Assuming VGA palette, assuming. So how would we check that? Convert color. Or 8 bits per pixel. I mean, these would not be shifted really at all. We're just setting these directly, so this doesn't really matter. I could do else to get this. Is it shifting? Oh, these are 0. Yeah. The linear mask size and field positions are going to be 0. I think this will still work down here, but I need to put the brace there. I don't know what I'm doing. I'm gonna have an else. That's what I'm gonna be doing. There we go. Else these are converted for the other. Okay. So then if I'm only taking B, the color is only coming in here as 2 or 0. Foreground should come in as 2. B should be 2. And it should put, this will be 0, ORed with 0, ORed with 2, shift left 0, ORed with 2. So the converted color should be 2. So foreground should be 2. So it should be green. I'm hoping, but it's probably not going to be green. Oh, it is. There we go. Okay, so that was all. I was setting them to 0. Since the mask size was 0, it was just putting 0 for everything. So the foreground and background were both 0, which is black. That's why nothing showed up. Here foreground is 2, but if we do the change colors command in 8-bit mode, it has 2 and 0, I just have 0xNN. So this will be a valid VGA color, not a 32-bit. If we want something like light gray, it would be 8, so I can put in 0, 8. And then light gray, if we want a dark gray, I could put in 7, right? So the contrast will be less though. So it's a little hard to see, but that's dark gray on light gray. It does work for VGA. It's just I can't put in, wild crazy colors. So that is all right. The only remaining things would be the graphics test thing, or I can put in sort of the user's able to change the graphics mode. So I kind of want to do that, so I'm going to do that next. That'll be in this bootloader file here. Alright, so the last thing I'm going to do today, I'll fix the graphics test probably later, and I won't really record that. It's just changing values from 1920 by 1080 pretty much. I don't think that's too significant. You can change them to whatever you want to be, but I'll show that when I'm done with it. But the last thing I'm going to do in this section that I'm recording now, the ability for the user to enter values on boot in the bootloader here to set the X and Y resolution and the bits per pixel. So I'm going to do that after we get the initial memory map here at the top of the bootloader. We're not doing anything with error, but I'm going to jump after this. We want to keep the carry set or not, just in case you want to check this later, which I'm not doing right now, but this will be, I'll have another label here. I'm going to call it inputs graphics values, for lack of a better word, and I'm going to jump to that here. Otherwise, it'll go there automatically when we finish getting the physical memory map. Right? Okay. So what I'm going to do this is to get user inputs, XY resolution, and BPP values. So since we set, I'm going to use ECX as a counter. So ECX was set up here, so I'm just making sure all of it is blank, not just the lower 16 bits. I'm going to XOR that. I'm going to see if we already have values by checking the width. So down here, we have width, height, and BPP. If one of these is set, we don't need to enter in anything. So this is, if people want to set these on their own when they compile this or whatever, they don't want to enter in on boot every single time what my X and Y and bits per pixel values are, just set these to some values. But if you do want to enter these every single time, I'm just going to have width be 0, right? Or all of them can be 0, it doesn't matter. But if one of them is set, I'm going to put already has values set, skip. When we set up the VBE structure down here, I'll have a label. Call it setup VBE. So I'm going to jump equal that here. So in my test I had resetting ES to 0. I guess I used that up here somewhere. I don't know, we'll find out in a bit, but I had that in my test, so I'm going to keep that there. That was in my notes. But just, we might be messing with the extra segment, so I'm resetting it whenever we do VBE info, because DI is at that location offset from 0. Anyway, how do we input the graphics values here? I'm going to have some strings that I'm going to set up that I don't have set up right now. But it'll be choose graphics string, the length of the string. I'm going to be printing strings here to the screen. So the length of the string is going to be right after. I'll have a dot length. And then I'm going to have a print string function if I don't already. So I can set up these down here. String constants and length values. I'll put graphics mode values. We'll do that. I'm still using FASM, right? Yeah, so we need the equal sign to set numeric constants, otherwise it'll be string constants and it'll deal with replacement, but we want this to equal a numeric value, however long this is. So I need to put the equal sign here for that. So I think in NetWide assembler you can just do EQU, but in flat assembler that doesn't work. For setting a numeric constant here, we need the equal sign, so that's why I'm doing this. Okay, I'm gonna have a height. I'm gonna have a height, a width, and a bits per pixel, so I'm gonna put those in. So height string, width string, BPP string. This will be height. Just doing that to save some typing. Width, or X and Y resolution, bits per pixel. So let's do X resolution, Y resolution, bits per pixel. Okay. If you can't see it, maybe now you can see it better up here. Just put in strings and lengths for those, and we'll enter those in over here under the input values label. So I'm going to move in the height string. That's what I called it. Instead of xres string, it's the height of the screen. Or we can do the width first, might make more sense. So we usually do xres times ys. I guess when we're saying 1920 by 1080, it's x by y. I'll do the width first. I'm going to have a separate function to input the number, which will be above the 32-bit stuff. So under here, I have a print string. Okay, I'll make a thing to print a string, which I'm going to extract from here in a bit. Subroutine to input a number. Okay, I'm just assuming I'm going to have these set up. These routines over here to input these values. And after we input the width, I'll move that into width. Some value, I'm going to put it in bx. So I can put outputs bx equals number. And we can do the same thing here for the height and the width, or the bits. That'd be the height and bits per pixel. Okay. Okay, and then after that, we'll retry. So we're not going to input the numbers if they're already there. That's what this compares for up here. This will be word value. But if they are, we're going to input the numbers, right? So where we go to actually input the numbers, I'm going to call print string down here. So how long is this right here? This is going to be 0x1234. So this will be 6. I'm going to do this, call print string. Or actually, if it'll be right under here, I don't need to do that. I'll put that under here. Address of string, cx will equal length of string. So under here, I'll move AH0EH, which will be the teletype output for a character. Load it, print it, loop back, and return. So that'll be fine. That's just a little function extract there. Okay, the number will be a little bit more involved, but we can make sure that that actually prints the strings first before we do anything else. That's invalid now. This number's invalid. This needs to be larger. Make it 1024. Which means second stage grew by 1. This will be 4. Which means that'll be 6. That'll be A, B, 2A, 3A. Yeah, because it grew by 1 sector. It's 2048 now. Which is 4 sectors, yep. Okay. There we go. The second stage here is 2048, 4 sectors. So this won't work, but prints an N. Well, that's good. I wanted to see if it would print the strings first, but I guess we're not inputting anything yet, so it's not going to work because it calls this. And this goes directly down and returns immediately. Yep, okay, so let's do that first. Actually make sure, nope, still printing in, nice, beautiful. Why does it do that? Oh, because it jumps, oh, because width is 0, that's why. I need to do not equal to 0. If it's already there, it's not equal to 0. So it wasn't finding any graphics modes with all zeros, so it went to where the end modes is, and that's just prints an N. That's why that was there. I need a new line here, but it does print those, so that's good. Y resolution was first. Even though it's width, width should be X resolution. I did Y, yeah, that needs to be X, that needs to be Y. Put that under there, there we go. I can put in 0A, 0D. Put a new line there first. 0A, 0D. Okay. See how that looks any better. There, that looks a little bit better. Input values xres, okay. Let's put in the number thing to actually input the number now. I'm going to hold it in bx. So I'm going to XOR that first. Just clear that out. Okay, I'm going to put in a thing to backspace as well because I typed this wrongly a lot and I couldn't recover from mistakes when I was testing. So I'm going to input the number in base 10 for the x and y in bits per pixel, and then if I make a mistake and I do a backspace, I'm going to divide the number by 10. So I'm just holding the 10 value here within cx. I could put it in cl as well, I guess, doesn't matter here. But I'm going to input each digit, so I'm going to have something called next digit, which will be called in a loop. I'll just put that down here. And I'll have another thing when we're done with it. Okay, so for every digit that they enter, I'm going to get a keystroke. So I'm going to print out the character, you know, teletype output. I'm going to see what they entered. If they entered in a backspace, I want to divide by 10. If they didn't enter in a backspace, I'm going to see if they press the enter key and we're done entering the number. So if they did press enter, the number is going to be in BX. I'm going to move it to AX, or well, the number's in AX. I'll move it to BX rather. BX is the ultimate return value. This is for up here. Okay, sorry, mine's scattered. If they did press enter, I'm trying to read my notes, they're not very good. I'm going to see if they pressed, you know, the enter key here. If they did, then we're done. We can return. If we're not done yet, then we need to convert the character to the integer representation. So they entered in a 1, subtract 32 from that to get a 1, an actual numeric 1, not the character 1, for example. Okay, then I'm going to do a multiply our bx value by itself by 10. Shorthand, you can also do this, but that's not actually an instruction. It's actually the 3. The assembler will convert that to the 3 operand instruction, so I'm just writing that here. So this will be bx times equal 10, and then I'm going to add al to that. So the reason I'm zeroing out AH first is because when we get a key up here, AH will equal the scan code after this. So I want to get rid of that scan code here. Or, well, AH will be 0E, actually. If I move 0E into AH, then that's still set over here, so I want to get rid of that. So we actually have just the AL value. Isolate AL value, okay. And then add it there. So that'll add the next digit to BX. And then we can jump to the next digit, okay. So that'll get a digit into bx. The next one, they'll multiply by 10, add it. So if they press backspace, I want to divide by 10 instead. So if we divide by a word value, I'm going to divide by a word value. So I'm going to divide by cx, which is 10, because I'll be using the div instruction, div. So div cx. And then we can move the result back into bx. So what this does, we'll take dx, ax divided by cx. Ax is the quotient, dx is the remainder on after the division occurs. So the quotient we want divided by 10, which will effectively cut off the last digit. If they entered in 1920 and then they press backspace, we want to lose that 0. So we divide by 10, the quotient is going to be 192. If they entered in 1928 and we press backspace, we want to get rid of that. The remainder would be 8, but we just want the quotient here, 192. That will then move back into bx. So that'll effectively divide by 10, chop off the last digit for a decimal number. And then we can go back to get the next digit again. Okay, and then when they're done entering, they pressed enter, we'll go to done, and we'll return. Okay. So when that's all done, we've hopefully entered in the width, the height, the bits per pixel, then we'll use those values and width, height, and BPP variables to set up the graphics mode that they chose. If that doesn't work, I'm not going to print these out anymore. This is commented. Don't need to verify. So if that doesn't work, if we have an error, it'll print F, but if we don't find any of those, we'll print an N and we'll halt. So I don't want to do that either. I want to go back and re-enter a new mode if that one didn't work. Okay. Okay, so I'm going to have another string for that. It'll be mode not found string $- mode not found string, and this will be video mode not found. We'll have try again with a Y, or take default value if I'm lazy, which I'm going to have be 1920 by 1080, 32. If they enter an N, we'll do that. We'll have that whole string there. So I'm going to move SI mode not found string. Mode not found string dot length, we'll print that out. Okay, and then I'll check if they entered in Y or an N. Okay. So XOR that again, we'll get the keystroke. Get a keystroke, see if they entered in a Y. See if they entered in an N, I'll have a thing called check no. But if they entered a Y, they want to retry, I'm gonna zero out the width, height, and BPP values, otherwise it'll go on and try to set the mode again up here. All the way up here, compare to 0. So I need to set this to 0 so it doesn't do that in this case. I'll set the other ones just as well. And then to put the text again on a different line, I'll print a new line. So 0E, 0A. We'll do that. And then we'll go back to input the values. Okay, so if they entered in a no, oh, we want to try again. So let me do, I did do a loop here. Try again. All right, if they did enter in an N, then we want to take the default values that I put. So here I'm just having the defaults be 1920 by 1080. You can make it whatever you want. and 32. And then we'll go to whatever the VBE was, setup VBE, we'll do that. That'll set the modes. Take default values. And hopefully those defaults are good for your system. If they're not, you can change them. That should be all we need to do. If they don't find it, we can input new ones. If it does find it, then we'll set them. If not, it'll take defaults. We'll just see if that all works, and it doesn't. 247. Yeah, what am I setting to 0? Nothing. Tract AL 0. That will convert it. And yeah, that didn't change the other sizes. Okay. So if we open this up, we can see, if we don't enter in anything, it'll say those weren't found. If we take the defaults with an N, it doesn't work, so that's good. If we do what we were testing before, still doesn't work. Okay. Okay, I found the issues here and fixed them, so I'm going to go through those right quick here. The second stage. Down here we're inputting the numbers here, the height, the width, the bits per pixel. I had move BX here, and not BL. This is a byte value, it needs to be BL. Down here where we're comparing under find mode in the VBE, this wasn't move AX. This wasn't erroring, but I changed this anyway to be consistent. BPP is a byte value, so instead of AX, I want to use AL there as well. And down here under end of modes, where we're checking after the end, we input the default values. I was moving a word, BPP is a byte value. I want to move a byte into there, so it's correct. Not a word value. That was the only thing in here in the second stage, the bootloader. I believe everything else was okay. So then after that, when I did make, the file amounts changed. The second stage is now 4 sectors, so I had to go ahead and change that in the file table. I changed that in here. This is a 4. These are all moved up by 1, but I did not change those inside of the boot sector. So I had to go ahead and do that. So the second stage bootloader, is now it's still at position 2, but we're reading 4 sectors here for the file size. So this needs to be 3, 4 minus 1. This needs to be 4 sectors, and it's starting at 2. That's the same. The file table, however, now starts at A. It's not 9 anymore. I had to change that. The kernel starts at B, not A. And the font starts at sector 6, not sector 5. Not anymore. So I had to change those. No more new things. Oh, I did add this for later on if I want to boot this on my laptop. I did add to zero out the extra and data segments. I forget if I went over that. Probably not. But that helped with my boot sector games, so I'm assuming it'll help here. Just zero these out first. But that's not useful now in this emulator. That might be useful later on actual laptop or something. That can help set the data segment first and extra segment just to ensure they're 0. Okay, but that should be it for second stage in bootloader. Oh, graphics. At the bottom inside of convert color, I'm just initializing this to 0 just in case. That actually shouldn't matter. It should be fine from here. But I just wanted to ensure it was 0 when debugging, so I set it to 0, and I'm going to leave it there. We'll just initialize that to 0 now. And the other changes were related when we actually changed the colors here in the kernel. Whenever I'm setting the background color, I'm not converting it in clear screen anymore. So I was doing convert color, right? With the background color, I'm not doing that anymore. Because I don't need to. When I call the convert color command, I want to convert the colors here. So just whenever I add clear screen within the command here, after the graphics test here, and after we return from running a binary file, I'm not using convert anymore. I'm just calling it with the regular user graphics info background color. Okay, so the only other change was in this command here to change. Change the foreground and background colors. This is what I had before, so I had to add to convert these. Otherwise, they were not being converted. They were stuck at the 32-bit values you would enter in. They need to be converted in case we're in a different color space, a different bits per pixel. If it's 16 or 24 or 15, it's not going to be the same as 32, right? So I have to convert these when we actually set the colors here, so that they'll be correct when we then go to clear the screen or print or do whatever. If that makes sense. Otherwise, they'd be the initial colors, which might not be correct. Got to convert them first. So after that, everything seems to run smoothly, and I'll show you that. Let's do a last double check here. It's 1F2 0. Yep, okay. So if we go to make, we can input stuff. If we take the defaults, it should be how it normally is, 1920 by 1080, 32 bits per pixel. It loads if I did an in there, and it loads everything. We can go and load stuff. And we're good. Calculator, okay. But if we put in something else, or we didn't like what we did there, put in a Y for something else, let's do something like 1024, 768, 15 bits per pixel. It'll still load. And this gray and this light gray is not exactly the same as in 32 VPP modes, but it's close enough because we did that convert color routine there. But if you don't like it, you can always change it. And it is converted, so these are correct after the conversions. For the initial values, those are correct for whatever bits per pixel mode we're in. If we did all E's, it should be the same for the foreground, background. We can set there, clear it, and check. So that's the same, but this is now 1F because it converted just 2 F's down to 5 bits per pixel. But that all works now, so we're okay with it. Yeah, we'll just set it to red, red and blue. That's fine, but we should be good to go now. You have colors, you can change them. You can change video mode. So that all seems to work all right. Okay, just a small extra thing here. I messed up text scrolling if it's not hard-coded for 1920 by 1080. As you see, 65 and 66, which is the bottom line of the screen, if you divide by 16, which is the current font height. 1080 divided by 16 was 66. That's what scrolling is hard-coded for. So if I try to load something like 1024 by 768, whatever, 16 bits per pixel, if I go to the bottom, it doesn't scroll until it reaches that line number. So I'd have to keep typing stuff until it eventually scrolls up, and it's not quite correct. We have this here, so how do we get something that's more generic and not hard-coded for this 1080p? Well, we can use the Y resolution we have now, divided by the font height that we have, which currently is set to 16, so I can just do that. We can just try that for now. Okay. And nowhere else. Okay, so that's just printing. We can try and see if that changed anything. (1024, 768), we'll do 32 bits. So does this, okay, now it scrolls. Somewhat. It doesn't really clear the bottom, but it does scroll at least. So it's a little better than it was. It is very slow. And that's not correct. What I can try to do for that is subtracting 1 from this, but we don't want that to be 15, so we want it to be 1 off of doing this, so that it's 1 line less. So we have that last line of characters that it should not mess with. It should overwrite that with the color right when it clears. So we need to subtract 1 from that. Probably also down here where we do it here, yeah. Do -1, so if it's greater than or equal to 1 line up from the bottom of the screen, you want to scroll down and then right over that last line after we scroll everything up here. We'll see if that changes at all. Just doing the same things I did before, 1024, 768, 32. So scrolling's still slow, but there we go. Now it leaves that last line that you can then type over now. That just fixes the text scrolling here. I know it's very slow. I'm looking into ways to improve that through double buffering or a memcpy or something that I can implement. But right now scrolling is slow, unfortunately. But I'm also recording and have a bunch of other stuff up on my PC. So the only other areas that I think that affected was in the editor, but I'll just make sure, at least for 65, 66. So we'll go ahead and change those things. 65. For the last line where we're in the text editor. See, right now, if we go to draw the keybinds here, it'll be off the bottom of the screen if it's not in the full 1080p resolution. So I got to make sure it corresponds to writing it to the last lines of the screen. So this needs to change. But since we have that header, we can still use this over here. We can do divided by 16, do -1, or maybe -2 if it's the last line. I'll see how that looks. If it's wrong, I can do -2. 66 was in, where is this at? The hex editor, okay. If we want to move down. Y resolution divided by 16. We'll try that. And the same thing here. Y resolution divided by 16. So that's at right bottom screen message as well. So I'll just see what those look like. The editor went up, of course. We'll change those. Okay. Let's do 800 by 600 so we have something really small that we can check. The scrolling still works. So if we go into the editor, okay, it's blue, which isn't great, but if we make a new file, we're one line off. It does print this here, but the last line I calculated is off the bottom. I need to reduce that again. And we also have blue in there, which is not great. Although it didn't find it. It puts that somewhere. That's background color, background color. Does it set that anywhere? That's interesting. So I don't have that set. Okay, oh well. Well, at the bottom screen message here, I'll subtract that by 1 and see if that looks any better. Then we'll check out the other issue. Okay, so that did work, but now they're overlapped. So the other one needs to be even less. Okay. Let's look at the hex part. So the hex editor does write it okay. So the -1 was the good way to go. As far as this, I need to search for this stuff. Yeah, so this I need to do -2 in the text editor. And where's this at? This is in the hex. Oh, that's the down arrow. Yeah, I can, just for future proofing, I'll make that -1 as well. See if that works. I'm really confused why it's drawing the screen as blue. Kind of confused there, unless I set the background color somewhere, which I don't think it is. I am converting here. Okay, it's the bit per pixel isn't converting correctly. Okay, because that's green and not blue. But we'll make a new, but the text is in the right place at least. So that's good. And if we go to the hex editor, it's in the right place. Okay. I wonder if I can reboot. It goes back to here. So if I do something bigger, like 1280 by 720, then we go to the editor. It should correspond, yeah, to the new bottom of the screen. That's what I wanted. If we do something large, like 1920 by 1200, It puts it at the bottom of the screen. So that's kind of dynamic now. As long as we use the Y resolution divided by our font height, that kind of makes it generic and dynamic, so it'll draw where it's supposed to, which is good. I am converting this. Well, that I kind of want to do. Wherever we're using the background color here is just set, and I think within the editor, yeah, I'm converting it again. So I only need to convert it initially. I don't need to convert it here because it already will be for whatever current mode we're in. I don't want to convert the background color twice because that'll take the new color, which is in a lesser bits per pixel. That's converted into that lesser color space, so it's a smaller number. If it converts it again, it'll make that number even smaller and it gets worse. So that's why it was blue or green before. I think it was just cutting off some more values that were there that don't need to be. I'll have to change all of these, but that's okay. Okay, so now we can see if that worked. That should be the last thing I have to do. 24,768, that's the resolution of my old laptop is why I'm doing that, because I want to see how it looks on this first before I try to test that. But there we go. So the color's correct and, this is correct. So that just fixed some text scrolling issues and some editor issues with the bottom line on the screen. But I will look into performance because, see, writing to the screen is fine, but scrolling is dreadfully slow. And I think that's due to reading from video memory and then writing to video memory 1 byte at a time. So, I could improve that by writing more than 1 byte at a time, or I think I'll look into like double buffering, write to a separate memory area. And then when that's all done processing, I can write just from, well, I guess that's still from a memory area, but it's to the screen, which is faster. I need some way of making this have a big speed up, because that's too slow, right? Even if I have a bunch of stuff going on. I'll mess with some things and have thoughts for future episodes. So if you don't like the text scrolling, I apologize, but at least everything's generic for graphics mode. And then the bugs should be fixed now, but the next video will most likely be over making fonts changeable and generic. I'll add like a couple of bytes for width and height to these font files. And I'll add another 1 or 2 font files for a different size, not 8x16, but like 10x12 or 10x18 or something larger, so that we can work with multiple bytes per line and then change the fonts out, see how things look, make it better for the user. Then after that, I'll do software and hardware interrupts with the interrupt descriptor table, maybe programmable interrupt controller for hardware interrupts, and maybe system calls if I don't take too long on those things. We can do system calls with int80h or something. So that'll be the one after the next one, but the next one of these I'll probably do font changing, making it more generic, and printing. Instead of hardcoding 16 for the font height, it'll be generic. But as always, I appreciate all you people for watching, and I'll see you on the next one.